Welcome back to eCoreAcademy, everyone. My name is Anita Raj, and I am one of the co-founders and teachers here. As you can see today, I'm bringing you all a new Algebra 2 lesson. Here we're going to be learning about quadratic systems. And I know it feels like it's been an eternity that we've been learning about quadratics, but quadratics is a very, very hefty unit. And guess what? We're almost done. This is our very, very last lesson before we move into our next unit, which is all about polynomials. So you'll be learning about cubic, quartic, and quintic functions. So we're going to start investigating functions where the highest degree or the exponent of x is going to be larger than 2. Because in quadratics, we go up to the x squared term. That's what denotes a quadratic equation. But then we'll be going into equations where we have x cubed, or x to the 4th, or x to the 5th, and so on. So that's going to be our next unit. And again, this is our last lesson in quadratics. So today we're going to be investigating quadratic systems. So we're going to understand how to find solutions to systems of equations that include linear and quadratic functions. So I'll talk about what systems of equations are on the next slide, but in this case, we're looking specifically at systems that include quadratics. So we're going to be looking at graphs with parabolas on them. And I'm going to be showing you the two main ways that we're going to be solving quadratic systems. One is which can always be your go-to is your graphing method. And then second, we'll be using substitution. We don't really use elimination method here, but if you just recall that from linear systems, it is another option. But in this video, we're going to be focusing on the graphing method and then the substitution method to find the solutions to quadratic systems of equations. Okay, without further ado, before we get into the video, I would really appreciate it if you all could first like this video, hit the subscribe button, hit the post notification bell, drop a comment down below, and share using our socials, which can all be found in the description box. Okay, let's get right into the video. So first, I'm going to be going over what quadratic systems are. Before we even get into what a quadratic system is, let's review what a system of equations are. It's when you observe two equations, systems, or functions and try to find the solution. You probably all remember from Algebra 1 where we investigated linear systems of equations. So where you had two lines on a coordinate plane, and then you're trying to see where they intersect. And their points of intersection indicate the solutions to the solution set. So the solution set is a coordinate that makes both of the equations true. So you'll have two linear equations of form y equals mx plus b. You'll graph them on a coordinate plane, and usually if they intersect once, which is typically what happens, if they intersect once, that coordinate where they intersect is the solution set. So that coordinate makes both of those equations true. Then you have the incident where they coincide, meaning they end up being the same line. And that means they have an infinite solution set. So every single point along both of those lines works for both of those lines. Then you have no solution, which means that both lines are parallel to each other. So remember, parallel lines just go infinitely in one direction. They never touch. They maintain the same distance from one another. So they will never touch. Therefore, they can't have any solution because they don't intersect at all. That is a linear system of equations. Generally, a system of equations is where you have two equations, systems, or functions. I just say two because that's usually what we'll be working with. If you remember three variable systems, we had three equations. Usually in these systems of equations, you're only going to be dealing with two equations or systems or functions. You can call them either of those three names, and then you're going to try to find the solution. And remember, the solution are multiple solutions. There can be multiple, and you'll see what I mean when we do these quadratic systems. The solutions are coordinate pairs, coordinate points on the coordinate plane that make both of those equations true. So the solution, like I said, is the point of intersection. It's where the two equations that are in the system of equations intersect or touch or cross. And below, I'm going to show you three pictures of the three possible outcomes that exist in a linear quadratic system. So again, there are three possibilities. I think I've shown you these drawings I made in a previous video, but there are three possibilities that exist in the linear quadratic system. And linear quadratic means you have, in this system, you'll have lines and then you'll have parabolas. So you have these linear equations and then you'll have these quadratic equations. So equations of the form y equals mx plus b, or equations in the form y equals ax squared plus bx plus c, or you'll get them in Vertex form. Just a quadratic equation and a linear equation. So here are the three possible outcomes when you're dealing with both a line and a parabola, and they're both in the system of equations. The first situation is two solutions, and I don't want to say this is the most common, but this is the one I see the most often, which is probably what makes me say that it's the most common. So as you can see here, there are two solutions, meaning right here is your line, this here is your line, and then this here is your parabola. And I think you can easily tell because you're familiar with these like graphs with these graphs. So the line here crosses the parabola at two locations. We have a location up here in quadrant 2, and we have a location down here in quadrant 4. So because they touch twice, both of these coordinates are solutions to this system of equations. So they satisfy both the equations for the parabola and the equation for the line. So in this case, we have two solutions. So this system of equations has two solutions. We have another scenario, because remember we have three. Here we have one solution. So one solution pretty much means that this line only touches the parabola in one location. So that's why we say one solution. And that one location is right here, as you can see. Hopefully you all noticed that this is pretty much on the vertex. This is the vertex. And if you think about it, that is really the only location you can have a one solution scenario. Because if you think about it, if I have this line intersect the parabola right here, while I cannot see the second and the line it looks something like this. While I can't see the second location that the line intersects this parabola, it's going to intersect it somewhere up here, even though I can't see it on this graph. That is why this parabola, this graph right here indicates that there's only one solution. So usually you'll see this is the vertex, and that is the situation where you will have one solution. So there's only one place where the line and the parabola intersect. So our last situation is no solutions. That means the parabola and the line do not touch whatsoever. And you can see right here, the parabola is opening upward. This line is going downward, and the slope of this line puts it in such a situation that it's never going to touch this parabola. So this line is just going to keep extending downward this way and then upward this way. And the parabola is just going to extend upward, and these two are never going to touch. So that is quadratic systems for all of you. Let's move into our first practice problem. Okay, moving on to the next slide, you're going to see our first problem, and I wrote graphing at the top because we're going to use the graphing method to solve this linear quadratic system of equations. So here's the problem. It simply says solve the following system by graphing. Our first equation is a quadratic, as you can see the x squared term. It is y equals x squared plus 2x plus 4. Our second equation is a linear term because you see it's in the form y equals mx plus b. It is y equals x plus 4. So we need to solve the system, meaning we need to find its solutions by graphing. And I'll show you exactly how to do that. On this next slide, what we first want to do is, at this point, because you're in Algebra 2, you should just be able to look at a linear equation and just be able to plot it just by looking at it. For example, y equals x plus 4. Just by looking at that, you should be able to plug in values for x, get outputs for y, and then plot those points on the coordinate plane. You shouldn't have to make an XY table. If you do, that's totally fine. Just to save time for yourself, you shouldn't really have to do that. As for the quadratic equation, it's totally explainable if you do need to make an XY table, and that's exactly what I'm going to show you on this slide. So we're going to find this XY table right here, as you can see, this XY table right here. We're going to make this. You can copy this down if you want right now, and then I'm going to go over it again. Then we're going to use this XY table. Then we're going to plot these points on our coordinate plane. We're going to plot the y equals x plus 4 line, and then we're going to find the places where these two intersect. So I'll give you a second to copy that down if you'd like, and then I'll be going over this as well. Okay, hopefully that was enough time. So I'm going to be reviewing this with you. So remember, our quadratic equation that we're working with in this system is y equals x squared plus 2x plus 4. So we're going to refer back to this while we're constructing our xy table so that we can come up with 5 points that we can plot so that we can actually show this quadratic equation as a parabola graphed on the coordinate plane. So first what we want to do the easiest thing to do is find the vertex of a quadratic equation. If you find the vertex, you're finding the center of the parabola, and it's going to be so much easier for you to construct points around the center of the graph. That's why we want to find the vertex first. To find the vertex, we got to look at what we've been given, and this here is in standard form. Remember, standard form is y equals ax squared plus bx plus c. And remember, vertex form is y equals a times x minus h quantity squared plus k. And remember that hk represents the vertex. So if we were given the quadratic equation in standard form, we could just derive the vertex easily. But here if we were given the quadratic equation in vertex form, we could derive the vertex easily. However, we've been given it in quadratic form, so we need to convert this. We can either convert it fully into vertex form, or we can just use these formulas that we know that I'm going to go over to find the vertex, which is exactly what we're going to do, because we don't need to completely convert this into vertex form. We just have to derive the vertex from it. So first we're going to find the x-coordinate of the vertex, which here is represented by h. And the x-coordinate is x is equal to negative b over 2a. Hopefully you all remember that. Remember, in this case, a is equal to 1, b is equal to 2, and c is equal to 4. So x is equal to negative b over 2a. So let's substitute these in. In this quadratic equation, b is 2. So we're going to have negative 2 over 2 times a, which is 1. So we get this. And then we're just going to simplify it. We're going to get negative 2 over 2 times 1, which is 2. Negative 2 divided by 2 is equal to negative 1. To get the y coordinate of the vertex, which in this case is k, we are going to simply take the x value, which we found to be negative 1, and plug it back into the quadratic equation we've been given, and then we will easily be able to find y. So we get y equals, and remember we're going to substitute negative 1 in for x in this quadratic equation. We get y is equal to negative 1 squared plus 2 times negative 1 plus 4. And if we continue simplifying this, negative 1 squared is equal to 1 plus 2 times negative 1 is equal to negative 2. We're just subtracting 2 here, and we just drop the 4 plus 4. And we get 1 minus 2 is equal to negative 1. Negative 1 plus 4 is equal to 3. So our y coordinate is equal to 3. If you combine these together, we can see that the coordinate for the vertex is equal to our x term and then our y term, which is negative 1, 3. So if we were to construct a xy table, what you want to do is you usually want to get 5 points for your parabola. The center point on your xy table should be your vertex. So I'm going to write negative 1, 3 down as my center point. Then we want to find 2 points with x values that are less than negative 1, and we want to find 2 points with x values greater than negative 1. So in this case, 2 points less than negative 1 would simply be negative 2 and negative 3, and 2 points greater than negative 1 would be 0 and 1. And what's going to happen is negative 2 and 1, these x-coordinates are going to have the same y-coordinate negative 2 and 0 are going to have the same y-coordinates. Because remember, you can think of a parabola as these two sides and they're reflected. So they're going to show the same y-coordinate. So that's why we do it this way. Because it's just going to be easier for us because we have to compute less numbers, let's put it that way. So we can plug 0 in for x in this quadratic equation. So we plug 0 in, we get 0 squared is 0. 0 plus 2 times 0 is 0. So 0 plus 0 is 0. 0 plus 4 is 4. So we get the point 0, 4. And we can just immediately assume that negative 2 is also going to go along with 4 because of that property I just told you about. And if you just envision a parabola, it looks something like this, right? And if we have the vertex here, we have 2 points here that are equidistant from the vertex. They're going to have the same y-coordinate. So you can think of negative 2 and 0 as those 2 points. The same applies to 1 and negative 3. If we plug 1 into this quadratic equation, we get 1 squared is 1 plus 2 times 1, which is 2. And then 1 plus 2 is 2. 1 plus 2 is 3. 3 plus 4 is 7. So we get 1, 7, and we get negative 3, 7. So we found our 5 points. What we're going to do from here is, I'll actually show you on the next slide, we're going to have to graph this parabola. So graphing again, we're going to have to graph this parabola, and then this line right here that you can see, this was our y equals x plus 4 line. So we're going to graph the two of these, and then we're going to find the places where they intersect. So let's do that now. I'm going to be showing you that all over again, and I'm going to draw it for you. So what we're going to do is we are going to let's begin by graphing the parabola. So our first point, let's graph the vertex. So our vertex is negative 1, 3. So the point would go right here. And if we're going to the right of it, our next point is 0, 4. And I'm taking this exactly from the XY table that we made. And then our next point is 1, 7. So 1, 7. Then we're pretty much going to reflect these points across the axis of symmetry, which is going to be x equals negative 1. Our next pair of points is negative 2, 4, negative 2, and then 4 right here. And then our last pair of points is negative 3, 7. So we can plot that right up here. And then we just want to connect the dots. So sorry if my parabola is a little bit sloppy, but hopefully that gives you a good idea of what this parabola will look like. Okay, so sorry about the sloppy parabola. Next, we got to graph our y equals x plus 4 line. And remember, we can just plug in values for that. So our y equals x plus 4 line. So let's plug in 0 for x to find the y-intercept of this linear equation. So if x is equal to 0, 0 plus 4 is 4. So we get the point 0, 4. So that will be our y-intercept, pardon me, because it intersects the y-axis. And that is actually a point that lies on the parabola. So let's leave that as is. Let's plug in 1 for x. So 1 plus 4 is 5. And I'm going to just draw that point right here. Let's plot another point. So 2. 2 plus 4 is 6. So see how this is increasing by increments. See how this is increasing by increments of 1. And if we go the other way, if we go down to negative 1, negative 1 plus 4 is equal to 3, which is also a point that it'll share with the parabola. And if we go down one more point, negative 2 plus 4 is 2, sorry. We get this point right here. So if I draw this line, it'll look something like that. And I'm sorry if it doesn't perfectly align with the dots, but it'll look something like that. And you'll see that this line intersects the parabola right here at its vertex and right here. So the two solutions, would be the vertex, which is negative 1, 3, and then the second solution would be the y-intercept of the linear equation and also of the parabola, which is 0, 4. So these two would be the solutions to this linear quadratic system. Okay, so let's move on to the next problem, and it is on substitution. So we are going to be using the substitution method. In this problem, you have the following, solve the following system by substitution. So here are the two quadratic equations. In this case, quadratic systems don't just involve one linear term and one quadratic term. You'll either have a linear term and a linear equation and a quadratic equation, or you might have two quadratic equations as you see here. So our first one is y equals negative x squared minus 3x plus 1. Our second one is y equals x squared plus 2x minus 2. Here's a solution already pre-written for you if you want to copy that down, and then I'll walk you through it again. So hopefully that was enough time for you to copy it down if you wanted to. I'll be showing you how to do that as I explain it to you. So here I'm going to write the two equations. Y equals negative x squared minus 3x plus 1. And then our second equation, y equals x squared plus 2x minus 2. What we're going to do first is, because both of these equations are equal to y, we're going to set them equal to each other, because technically they are equal to each other. So what we're going to do is I'm going to rewrite this as negative x squared minus 3x plus 1. And think of it like I am substituting this right here, this x squared plus 2x minus 2, in for the y in the first equation, because technically both of these equations are said to be equal to y. So negative x squared minus 3x plus 1 is equal to x squared plus 2x minus 2. Then what we're going to do is let's move all of the terms over to one side of the equation so we can get this equal, we can set it equal to 0. So if I add negative x squared to both sides of the equation, I end up getting 2x squared. If I add 3x to both sides of the equation, I get plus 5x. And then if I subtract 1 from each side of the equation, I get negative 3. We pretty much eliminated the left side of the equation, and now we have a quadratic set equal to 0. So now we can actually solve. So what we're going to do is we're going to factor this right side of the equation. And if you factor it, I'm not going to explain how to factor it because at this point you should be able to factor it. You should be able to get 2x minus 1 times x plus 3. Because remember, I'll just go over it briefly. These two terms right here that you add at the end of the expressions within the two parentheses, what multiply together, they have to equal this term right here, the c term. So if you break negative 3 down, you have to have either negative 1 and 3, or you have to have negative 3 and 1. In this case, negative 1 on the first parentheses and 3 in the second parentheses work. Then you have to separate this 2x squared by 2x and x. So if you have 2x and x in the two parentheses, and then you have a 3 and a 1, you have to decide which goes where, and then you need to decide the sign change. So if you multiply this out, you get 2x squared plus 6x minus x, which gives you the 5x minus 3. So this is what if you factor it, that's how you would get it. And that's the guess and check method that I taught you in an earlier video in this quadratics unit. So those are the two expressions that we're going to be working with. And remember, what you can do is you can set each of these equal to 0, and you can solve for x in each of these parentheses. That's how we get the two different solutions. So let's solve for x in the first set of parentheses. We have 0 is equal to 2x minus 1. Then what we can do is we can add 1 to both sides, and we get 1 is equal to 2x. And if we divide both sides by 2, we get x is equal to 1/2. But remember, we're not done, because to find the actual solution set, we need a coordinate. So we need to solve for y as well. To solve for y, we can just plug 1/2 back in for x in one of these equations here. For example, I'm just going to pick x squared plus 2x minus 2 because it's just the easier one to work with. So we're going to plug 1/2 in back into y equals x squared plus 2x minus 2 in for x. So we're going to get y is equal to 1/2 squared plus 2 times 1/2 minus 2. And then we're going to get y equals 1/2 squared is 1/4 plus 2 times 1/2 is 1 minus 2. And we end up getting y is equal to negative 3/4. So our solution is going to be the actual coordinate. And the coordinate is 1/2 negative 3/4. But don't forget, that's not the only answer. We also have here 0 is equal to x plus 3. So we have to solve that as well, because this has two solutions. So we get 0 equals x plus 3, and this is pretty simple. We just subtract 3 from both sides. We get x is equal to negative 3. Let's plug negative 3 in for x into y equals x squared plus 2x minus 2, like we did with the last one. And we get y is equal to negative 3 squared plus 2 times negative 3 minus 2. Y is equal to negative 3 squared is 9. 2 times negative 3 is negative 6 minus 2. And then we get y is equal to 9 minus 6, which is equal to 3. 3 minus 2 is 1. So y equals 1. And this solution right here is negative 3, 1. So here are our two solutions, 1/2, negative 3/4, and negative 3, 1. And we just found those using the substitution method. Finally, let's do this problem about inequalities, and I'll show you what this problem is all about. So here's the problem. Solve the following system of inequalities. So treat this exactly like you would a system of equations. In this case, the equal sign has been replaced by an inequality. So either you'll have a greater sign, a less than sign, a greater than or equal to sign, or a less than or equal to sign. So here we have to solve the following system of inequalities. We've been given two quadratic inequalities. What we need to do is we need to graph these on a coordinate plane and find the region that satisfies both of these inequalities. So hopefully when you were learning how to graph just linear inequalities in Algebra 2, you remember graphing either a dotted or a dashed line, and then you were shading either the region above or below that line. And that's exactly what we're going to be doing here in this system of inequalities, but instead of having linear inequalities, we're going to have quadratic inequalities. So on this next slide, what we're going to do is we're going to do pretty much what we did in the very first problem where we were graphing. We are going to take this quadratic system, both of these quadratic systems, because remember we have two, and we are going to be finding the vertex, and then we're going to be finding points around the vertex so we can actually graph these parabolas. So here is the work already showed. If you want to copy that down, feel free to do so. I'm just going to show you all of this over again, and I'm going to write it, and I'm going to go over it with you. Okay, hopefully that was enough time if you wanted to copy it down. So here is the first inequality that I showed you on the last slide. The first one is y is greater than x squared plus 2x minus 3. So this is the first inequality we're working with. We want to find the vertex, and then we want to find 4 other points. So remember, your key is 5. You always want to find 5 points for your quadratic so you can actually form a good curve, unless your teacher actually tells you that they want a specific amount of points. Otherwise, 5 should be your go-to. So let's find the x-coordinate. Remember, x is equal to negative b over 2a, which is in this case is equal to negative 2 over 2 times 1. We get negative 2 over 2 equal to negative 1. So that is our x. Let's find our y by plugging negative 1 in for x. So we get y is equal to negative 1 squared plus 2 times negative 1 minus 3. We get negative 1 squared is equal to 1 minus 2 minus 3. 1 minus 2 is equal to negative 1 minus 3 is negative 4. So our vertex, we can conclude, is equal to vertex is equal to negative 1, negative 4. Next, we want to kind of imagine what the graph is going to look like. Remember when I was talking about those dotted or those dashed lines and that shading? So let's look at our inequality now, and then let's plan ahead so that we know exactly how we're going to graph this. Well, first, let's look at the actual sign. So we have a greater than sign. So y is greater than the rest of our quadratic. So because we have a greater than sign, we're going to shade upward. So we're going to shade above the parabola. So I'm going to write shade up. Remember, if you had a less than sign, you would shade downward. So shade up. Then we have a greater than sign. We don't have a greater than or equal to. If you just have a greater than or less than sign, you're going to have a dotted line, because the actual points that lie on the line itself of the parabola are not included in the solution set. If you have a greater than or equal to or less than or equal to, you're going to have a solid line. So what that means is that the points that lie on the parabola, on that actual line, are included in the solution set. So in this case, we don't have a greater than or equal to sign, we just have a greater than sign. So we are going to have a dashed line. So dashed line. Now we got to find some points that are going to go on our xy table. Remember, the vertex goes in the very center. So our vertex is negative 1, negative 4. 2 points less than negative 1 are negative 2, negative 3. 2 points greater are 0 and 1. So let's plug these points in. So if we plug 0 in for x, we get 0 squared, which is 0, plus 2 times 0, which is 0, minus 3, which is negative 3. So our y-coordinate is going to be negative 3, and our y-coordinate for negative 2 will also be negative 3. If we plug 1 in, 1 squared is 1, plus 2 times 1 is 2, 2 plus 1 is 3, and 3 minus 3 is 0. So our y-coordinate is going to be 0, and our y-coordinate up here is also going to be 0. So let's repeat that exact same process, but let's do it with the second quadratic inequality we were given. The second one we were given was y is less than or equal to negative x squared minus 2. So this is the second one. So we're going to have x is equal to negative b over 2a. We're repeating the exact same process, which is equal to, in this case, if you see, we have an a term and we have a c term, but we don't have a b term because we don't have just a linear x term. So therefore, our b term is equal to 0. So we end up getting 0 over 2 times a, which is equal to negative 1. Then we get 0 over, so I accidentally wrote negative 1 over here. I'm checking my work. Make sure you have negative 2, but it really doesn't matter because at the end of the day, 0 divided by negative 2 is just going to give you 0. And down here, we end up getting, we're going to plug 0 back into this quadratic equation. We get y is equal to negative 0 squared minus 2. This is equal to 0. Well, negative kind of cancels out. You don't really need negative because it's 0. 0 squared is equal to 0 minus 2, and then we end up getting negative 2. So we can deduce that our vertex is equal to 0, negative 2. Then we have to determine how we're going to dash and what kind of line we're going to use. So because this is a less than sign, we're going to shade down. So we're going to shade downward. Additionally, because this is a less than or equal to sign, we have to consider that the coordinates that fall on the actual line of the parabola are part of the solution set. So we are going to use a solid or full line. So solid slash full line. Solid or full line. So now that we have that figured out, let's actually make our XY table. Remember, your vertex goes in the middle, so our vertex in this case is 0, negative 2. 2 points less than 0 are negative 1 and negative 2. 2 points greater are going to be 1 and 2. If we plug 1 in, 1 squared is equal to 1, and negative is equal to negative 1. Negative 1 minus 2 is equal to negative 3. So we're going to get negative 3 for negative 1 and 1 corresponding with those two. And then we're going to plug 2 in. 2 squared is 4. 4 times negative 1 is negative 4 minus 2 is negative 6. So we're going to put negative 6 down. So this is how we solve this part. I'm going to go right on to the next slide where we're going to actually be graphing these. So here's a graph of these two equations. And as you can see, one of them is dashed, one of them is solid, then we shade, and then when we shade, we can see that the area right here that is very thickly shaded, this is going to be our solution region. So you would indicate to your teacher, this is the area that contains any possible solution. So any coordinate that falls in this shaded region right here, it satisfies this system of inequalities. I'll show you exactly how to graph it on this now. First, let's graph the points that we found for y is greater than x squared plus 2x minus 3. So we're going to use that xy table that we found. So the first point we're going to graph is obviously the vertex. And recall that the vertex is negative 1, negative 4. So I'm going to plot that right here, negative 1, negative 4. The next point we're going to plot is right off to the right. We had 0, negative 3. And remember, I'm just reading this right off of the xy table that we made together. And the final point is going to be 1, 0. So I'm going to plot that right here. On the flip side, we have the next point, we have negative 2, negative 3. So I'm going to plot that as well. And then finally, we have 0, negative 3. So I'm going to plot that. Remember, this one was a dashed line because it was just greater than, it wasn't greater than or equal to. So I'm just going to indicate that this is dashed. So sorry if my dashes aren't perfect, but here's the dashed line to indicate that. And remember, because it said greater than, we have to shade above. So shading above, I'm just going to draw some lines. So this area right here contains all the solution sets for this parabola. So now we have to actually draw the second parabola. The second parabola, its vertex was at 0, negative 2, which is right here. The next point was 1, negative 3, so 1, negative 3. The next point was 2, negative 6, so 2, negative 6. Remember, I am just reading from the xy table we made again. On the flip side, if we look on the left side in quadrant 3, we have the point negative 1, negative 3 that also falls on this parabola. And then finally, we have negative 2, negative 6, so right here. And remember, this one was less than or equal to, so we're going to have a solid line. Because remember, the solution set, the coordinates that fall in the solution set can also fall on this actual line that indicates where the parabola is. And because this is less than, we have to shade below. So we're going to shade underneath it. If you see this region right here, where the two parabolas kind of intersect, that is going to be the region where all our solutions lie. So that's how you would do a quadratic system, but a system of inequalities. Well, that's all I have for you for this video. Please look for my next video, which is going to be going over how to use the TI calculator, and I'm also going to be reviewing how to solve any quadratic equation. Then we'll be moving on, speed railing into our next unit, which is all about polynomials. In the meantime, I'd really appreciate it if you could hit the like button, the subscribe button, the post notification bell, And if you could drop a comment down below, and lastly, share using our socials, which are Facebook, Twitter, and Instagram. Also, check out our website when you can. You can see all the cool functionalities we have on there, like notes and quizzes to go along with all of our lessons. Finally, if you have any business or personal correspondences, feel free to shoot us an email at eCoreAcademy@gmail.com. Have a great day, and please look out for my next video. Bye!